The problem is from GATE 2018 mathematics paper, question number 21. The problem given is let C of 0, 1 be the real vector space of all continuous real valued functions on the closed interval 0, 1, and let T be the linear operator on C of 0, 1 given by T of f of x equal to integration 0 to 1 sin of x plus y f of y dy, where x is in the closed interval 0, 1. Then the dimension of the range space of T equals to. So it is asked to calculate the range of T. Sorry, the dimension of range of T. So the NPTEL reference to solve this problem is Module 4, Lecture 15. The title of this lecture is The Null Space and the Range Space of a Linear Transformation. This lecture is by Professor K.C. Sivakumar, he is from Department of Mathematics, IIT Madras. Even you can watch this this reference video using this YouTube link. So now coming to the solution. So it is by just looking at this integration, one can think of it is difficult. But when you put pen on paper, you can see it can be done in a single minute, in 1 minute. So it is given f of x is integration 0 to 1 sin of x plus y f of y dy, where x is in 0, 1. So we have to calculate this expression. The integration is this expression is a linear combination with how many linearly independent vectors for each given f. So for this, since in the integration you can see it is given sine of x plus y. So when we expand sine of x plus y using the formula, we get this as sin x cos y plus cos x sin y into f of y dy, and hence it can be written as integration 0 to 1 sin x cos y f of y dy plus integration 0 to 1 sin y cos x f of y dy, and since the integration is with respect to y, so we can take the terms involving x outside, that is sin x integration 0 to 1 cos y f of y dy plus here we have cos x integration 0 to 1 sin y f of y dy, and when we assume the terms involving x, since this is this is dependent on y, and since the limits are finite, so we can say this total integration is some finite value, and hence we can say these are some finite values, and I am assuming these finite values as a and b, which are independent of x and y. So where a is integration 0 to 1 cos y f of y dy, and b is integration 0 to 1 sin y f of y dy. So so these are scalars that you can see easily, sir, that these are having finite values, since f is continuous on the closed interval 0, 1. So cos y times f of y is continuous, and since it is on the closed interval compact interval 0, 1, so it is bounded, and hence the total integration is bounded. In similarly, b, the value of b is also finite, so these are finite values, and I'm assuming those two values are a and b. So for any vector f of x in C of 0, 1, we can write tf of x can be written as sin x times a, or a times sin x, some scalar times sin x plus b times cos x, where a and b are scalars. So we can see sin x comma cos x generates the range of t. Therefore, dimension of, and we can see these two vectors are linearly independent, sin x and cos x. So we can say dimension of range space, range of t is equal to 2. Hence the answer is 2. So not only this problem, when you look at some problems, you can feel difficult to solve by just looking at the expression or some the terms given in this in the problem. But when you put pen on paper and try to solve, you can get some idea, and using that idea, you can easily solve that problem. Here also, you can, by just looking at this integration, one can think of it is a little difficult to calculate the dimension of the range space. But when you just applying the formula for sine of x comma y, you can easily in the next step only you can see the dimension of range space. So here the answer is 2.